Hello everyone, my name is Qasim Ahmed. I'm here from Karabakh University with Dr. Qasim Oscar to present to you our paper that is titled User-Generated Content-Based Educational Ecosystem in the Metaverse. So today we're going to talk about the Metaverse. What is it? Why does it matter? What role does it add to an educational environment? And how can we improve it? We're also going to talk about user-generated content and how does it fit into the Metaverse and our implementation of user-generated content. We're also going to talk about tools like Unreal Engine 5 and geometry scripts, and methods like real-time Boolean operations and algorithms that we used, and our implementations such as creating specialized models from smaller, more general-purpose models. The Metaverse. It's a virtual interconnected space where users can interact with computer-generated environments and other users in real time. It's a virtual shared space that blurs the line between physical and digital reality. Well, what does that mean? In short term, it's a more immersive digital environment, and it comes with all the benefits and creativity and limitations of a digital world. Some papers consider it to be the third wave of internet revolution. The metaverse enhances education by providing a more immersive and interactive virtual environment. But as it currently stands, it lacks a lot of the customizations and variety. Everything you see is pre-made by the developers or creators of this particular metaverse, and you have little to no control over anything to make it fit your needs. User-generated content, by definition, is content that is created by individuals rather than developers, enabling users to contribute and share their own creations within a platform or a community. It allows the users to be in an environment that's more immersive and customizable to their own needs. While we were looking through all the major scientific journals with search terms related to our topics, we found that most of the papers mentioning user-generated content or the metaverse are not related to creating environments or providing any extra customization for the user. Most of them were survey and security-related research. Some of the notable papers that we came across in our literature review were papers such as Crypto Dropout to create unique user-generated content using crypto information in the metaverse. They tackle adding uniqueness to user-generated content in the metaverse and use methodology like crypto and neural networks. They also come with some limitation, like some neural networks having much higher weights than others, resulting in unpredictable output when adding randomness. Another paper was titled User-Generated Worlds. It finds that a user-generated content-based microverse provides an avenue for creative expression, particularly in education and skill development. However, they rely on unpaid child labor and raises concerns about addictive tendencies in children. The scope of this paper was also limited to two of the major games with user-generated content, such as Minecraft and Roblox. The third paper was titled A Survey on Metaverse Fundamentals, Security, and Privacy. It acknowledges the need for tailored security solutions for the metaverse and also discusses challenges about wearable XR devices and the constraints that comes with them. The last paper that we will mention today is titled Metaverse in Education: Vision, Opportunities, and Challenges. The paper suggests integrating the metaverse with education using emerging technologies to enhance equality in education and generally providing more opportunities. So what is our current problems? One of them is maximizing the learning experience relies on the establishment of an optimal environment, which classroom layouts influence student performance. It also utilizes virtual or augmented reality, offering a digital space for real-time interactions. But the current metaverse solutions lack flexibility and customization due to the absence of user-generated content, restricting the variety of available environments and layout options. We think that when a user doesn't feel comfortable in an environment, they usually try to avoid it, and that's why we try to provide as much customizations and options for each user to allow them to create a space that fits them and is immersive for them. So what are we trying to achieve? Well, the goal of this paper is to develop a framework that provides the following. Environment customization. That means being able to change the look, the shape, and the feel of the environment, such as changing the size, the model, the lighting, and interactability with other objects. The ability to add and expand the base framework. That means the framework must be built in a way that allows other developers to add more themes, models, and other elements with ease. The ability to share the created content with others. That means the framework must provide a way that allows other users to share the experience and also allow you to share your created content with other users and invite them into your world. Intuitive controls through simple and user-friendly sliders. We want to provide the users with an easy way of controlling the customization in the environment. If it is too technically difficult, they will probably opt out of the experience. The main tool that was chosen to develop this framework was Unreal Engine 5 alongside with its one of the new plugins called Geometry Scripts, and it was chosen for a variety of reasons. Scalable graphics means that the users and the developers can set their own level of graphics that works best for their own device. They don't have to rely on a preset or a predetermined set of rules. They can adjust it based on their needs and their preferences. Cutting-edge technologies enables a current and future scalability and an increase in immersion, such as using Lumen for realistic global illumination and dynamic lighting, and using Nanite for generating a consistent level of details and performance. These two features are currently only available in Unreal Engine 5. Open source means that anyone that wants to build upon this work can easily achieve that without running into any major problems. This tool also provides a very good level of documentations for every part of the engine. It's also backed a very strong community of developers and creators with a vast amount of open and free learning resources online. It is also one of the more popular tools around the world, used in various different type of projects such as AAA game development, AR and VR development, and other type of 3D and visual production environments. One of the main goals of this framework is to streamline the hard parts and package them into small modules and provide an example on how to use the modules to create dynamic environments. For example, instead of figuring out how to make a window from scratch or add a table or add a chair, the framework provides a node that does that for you. All you have to do is tell it how many you want and where you want it. Now let's talk about some of the methods and algorithms that were used in this project. For the main environment, we used real-time geometry manipulations. For added props and meshes, we used math-based algorithms for placement. We also used Lumen for dynamic lighting to remove the need for light rebuilding, and they all connect together under the hood to build the framework. In the next few slides, we will talk about each one of these in more details. The way we achieve real-time geometry manipulation in Unreal Engine 5 is by using a plugin called Geometry Scripts and Boolean operations to build the main environment, walls, and boundaries. Combining multiple of our modules together allows us to create a simple set of rules that uses simple values to create any type of shape we want. As you can see in this video, we're using a basic set of numbers to create any type of window we like with any length, size, and location. And all of this can be achieved in real time as the user is experiencing it. Boolean operations consist of taking one 3D mesh as a base and subtracting or adding another 3D mesh into it. In this simple demo, we demonstrate how a simple Boolean operation works under the hood. As you can see, we take our execution pen into an append box with three simple values, width, height, and length, that can be controlled through the editor. Once we place our demonstration script, we see that we have the same values that we specified, and they determine the shape of the box. Continuing our demo, we connect our execution pen into an allocate compute mesh. That simply just makes a temporary mesh for us to use as a tool. And we use a transform location and variable that we can control through the editor, and connect that execution pen into an append cylinder. And that goes to an apply Boolean node that takes our cylinder and uses it as a tool to apply the Boolean operations into our base mesh, that is the box we created. And then we simply just release all computing meshes for performance reasons. As you can see, the Boolean operation is already happening from the center of the mesh, and we can move the actual variable to determine the precise location of the Boolean operation, and we can still dynamically control all the other variables to facilitate any shape we like. This is the basic underhood workings of our framework. This is a very simple example of it, but a more complex example was used to build the previous demo that was shown for multiple windows. Algorithm-based mesh placement. Using mathematical algorithms, we can choose how to place meshes into the environment without the need of any manual work. Here's an example of our algorithm in work. As we can see, we can use simple checkboxes and set of values to determine the location of a singular chair or a grid of chairs. We can determine the location, we can determine the spacing between the chairs, and we can determine whether we want them in a circular fashion or in a grid fashion. This, of course, doesn't have to be a chair. A chair was just used for the appropriate theme. So taking a look at one of the simple algorithms that was used in the previous example, this is the circular placement algorithm for the chairs. This algorithm relies on a set of 3 values. All we have to provide it is the chair's location, and then the spacing between the chairs, and then the grid size. These values plug into a create circular path 2D, which takes those values and creates just a simple 2D circular path, and then we convert those into a poly of arrays, and then for each point in that poly of arrays we run a set static mesh component, and then we add the static mesh component. Currently, static mesh is the chair. It can be anything we want. We're also using the wall's thickness variable from our base environment to determine the height of the chair's placement in case the floor is higher or lower. And we're also using the find look at rotation node that is provided by Unreal to find the exact rotation that each chair needs to have to look into the center of the mesh or into the center of the mesh with our added variables to change the rotation. Interactable objects are any type of 3D meshes or 2D UI with added functionality, such as a whiteboard you can draw on or controls for the sun's location in the sky. Each object has its own custom functionality that can be made using provided tools from the framework or provided tools from the engine. In this demo, we are currently in VR drawing on the whiteboard we talked about earlier. Here, as we can see, we can choose from different set of pens and we can draw anything we like. We can also clear the board by touching the bar in the bottom, or we can switch between any type of pen we have provided or any kind of custom pen that any other users provided or any other users have uploaded themselves. This is an example of a custom interactable object. Using Unreal Engine 5's new rendering mode Lumen, we can create a dynamic and realistic looking lighting without the need to rebuild every time we change something. This is another example of an interactable object. Here, as we can see, we're using a globe to determine the location of the sun, and we're also using Lumen to render that sun in real time. We're changing the lighting and the effects in the sky using as atmospheric effect to calculate real-time global illumination and convey realism. Of course, as mentioned before, Lumen does come with some performance cost, but the good news is the user can choose to enable it or disable it. And finally, we can use UI to put all of those functionalities together and give the end user simple controls like sliders and checkboxes to create an immersive and dynamic environment such as a virtual classroom. And in this demo, we show how we can use user interface to control all of those values that we talked about from the previous slides and all of those methods and functionalities in real time and create our environment in any shape and form we like. We can use all the previous mentioned methods and all the previous mentioned modules to combine these values in any way we see fit to create our environment. The UI shown in this demo is also reusable and modular. It doesn't have to be in this shape or in this size or in this form. It can be modified to fit the needs of any of future developers that want to expand on this framework and modify it to their needs. All of these methodologies can be used to create a specific environment or a classroom for each university in a theme of that university or for each teacher and his class needs. while having the ability to invite other students or other users into that world to share the experience. In conclusion, to build a framework that provides scalability and integrability, we need to build modules that work on basic values using smaller, more general tools. And in order to enhance education in the metaverse, we need to provide an engaging and personalized learning experience for the users. Using the methods and tools in this paper, we can build a more immersive environment for any subject that benefits from variety and customization. For the future, we plan to conduct user studies to provide us with more information about the preferred methods of the user interaction and patterns to enhance the experience. We are also planning to keep expanding and improving on the tools for the framework and providing the creators with more options and customizations and establishing ownership of the environment they have made. And we want to provide future developers more ways to integrate different types of systems into this framework to make it more expandable and scalable. I wish everybody a good rest of their day, and thank you for listening.